Hello everyone, welcome back to another exciting edition of Learning Math at Home. Today's new topic is talking about how to graph a circle in the coordinate plane. So you see here I've written an equation, boxed in orange. You might want to jot this down because you're going to be using this a lot today. The equation states that parentheses x minus h, close parentheses, squared plus parentheses y minus k, close parentheses, squared equals r squared can graph any equation of a circle in the coordinate plane. So let's break that down and make sure that we know what HR and HK and R stand for. We all know what X and Y are, hopefully. That's the axes that you graph the circle on, so the x-axis and the y-axis being here. And X and Y really is any point on that circle that it could represent. Now, the values that we plug in here are going to represent the center of that circle. So in this case, the center of the circle where I graphed it in my example happens to be both in quadrant 1 for X and Y. So it's going to be positive in these cases. So you'd be subtracting those numbers. The R stands for the radius. So when you see that radius, that's any distance from the center of the circle to the edge of the circle. That distance is R. And this formula supposedly will get you a circle. And I'll explain why in a minute, but for right now, I want you to go to Desmos and let's do a couple practice problems on graphing these. So let's say we want a circle with a center 0, 0. Let's say we want it centered right at the origin. Okay, so that coordinate 0, 0 then would become x minus 0 squared plus y minus 0 squared. Now we got to have a radius. So let's say we want a radius of, I don't know, 1 equals 1 squared. Well, that would be your equation. Now let me zoom that out so you can see all the components. 0, 0. Would I need those zeros if it was just the origin? Well, not really, because x minus 0 is x squared. And what is 1 squared? It's 1. So you see, that's really the same thing, okay? That forms a circle. So what happens if we want to shift it left, right, up, or down, or make the radius bigger? Well, let's start with changing the radius. Let's say I want the radius to be 2. Well, then I would square 2. If I want it to be 3, I could square 3, and so on. I could make that radius as big or small as I want to. I could make it even, 0.2 if I want. It'd be really tiny. I could zoom in, and you can see that radius is 0.2, okay? So let's keep that at, we'll just do 2 squared there and make it a relatively normal size circle. Now let's play around with the numbers in here. Let's say I want it shifted from 0, 0 to maybe 2, 3. All right, well then I would have it, if I wanted to go right 2, I'd be minus 2, and that made it right 2. And if I wanted to go up 3, I would be minus 3. Notice that the subtraction let us go the opposite direction. So the negatives in the formula lend itself, so that it's going to be the opposite of whatever the sign of the axes is. So if I wanted that to go left 2 and down 3, I would need those to be pluses. Plus 2 would be left 2. Down 3 would be plus 3 in the y value. So you see that center is now at negative 2, negative 3. And I could make that any number I want. I can make that minus 5, and that would be up 5 again. Still left 2 and up 5. So the center is always going to be basically the opposite of these these numbers. So if that's plus 2, the center would be negative 2. And since that's minus 5, it would be 5. And you can see that point plotted right in there at negative 2, 5. As far as the number at the end, 2 squared is equal to 4. So whether you said 2 squared or 4, that's going to get you the same result. Okay, we'd like to make that as simple as possible. So that would be the best way to write that equation if I wanted the center at negative 2, 5 and the radius to be 2. So that's just a little introduction as to what this formula looks like and how it gives you a circle. If you're interested, I'll extend this video to show you where the formula comes from. If you got the idea, we'll start, you can close the video and start looking at the other videos for examples. So this formula, if you think about the distance formula, well, let's back up first. So if you think on a coordinate plane, the distance between any 2 points we'll call that D, can really be thought of as the hypotenuse of a triangle, with the legs of the triangle being the vertical and the horizontal distances. So let's say I knew that, let's call that x1 and x2. And we'll call this, sorry, x1, y1, and we'll call this x2, y2. Well, to get that distance, I would have to know the vertical difference, which is the difference between your y values. So that would be y2 minus y1. And the horizontal distance would be the difference between your x values. And in the Pythagorean theorem, we know a squared plus b squared is equal to c squared. So the distance formula comes from Pythagorean theorem. Consider that being your A. I'll put my A here and my B there. My B value would be the difference in your Y values. It doesn't matter if your A is the vertical or horizontal. What's important is the distance is your hypotenuse. Well, in this case, we can kind of stretch that to be a circle. So instead of being x1, y1, x2, y2, we can think of a circle being any point that is the same distance from a fixed point on the circle. So that point there, that distance happens to be your radius. So whatever that distance is, it's the same there, 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 there. That's your radius. So we're going to replace the distance with r. And let's just call this, instead of x1, y1, we'll just call it x comma y. Any point on the circle, we say x, y. The distance between any 2 points, we'll call the center h and k, is the difference between your x values, so in this case, x minus h, and the y values, y minus k. And that'll allow you to basically use the distance formula and substitute the x 2's and y 2's with x and y, and the x1 and y1 with h and k. That's just your center of your circle, and that distance is your radius. So that'll generate any equation in a circle. So that's just a little bit of an insight as to what the equation of a circle looks like, how to graph it on Desmos. And the next videos, I'll go over some examples on identifying centers and radiuses and being able to graph them.